All right, so this question says we have a loop-to-loop here, and it has a radius of 18 meters, and a car is going to get shot here, and it's going to travel around the loop-to-loop and come out the other side. And the first part, it says, what is the minimum speed at which the car must travel here so that it can safely travel the loop-to-loop? And then also, what is the speed at the top in this case? So here's how we're going to attack this question. If there's going to be an injury or if something bad is going to happen, it's going to happen right here at the top of the loop, right? So if we think about our loop-to-loop, right, when we're right here, we would normally have two forces acting on us. We would have the force of gravity acting down, and then we would also have a normal force acting down as well. So what's going to happen is as I am starting to move up the track in this direction, my body is wanting to follow this path. So I'm wanting to go upwards. And so the track is actually going to push down. And really the faster that I go upwards, the more it's going to push down. So the slowest as I go slower, the less and less I'm going to want to go upwards. So the less and less this normal force is going to be. So the slowest would be when my normal force equals 0. So in that case, then the only force that would be acting would be this gravitational force, okay? And so my acceleration, centripetal, is going to simply be g, or 9.8, or 10, whichever one you want to use. So we're actually going to need to find this first, and then we'll be able to find the speed at which it needs to get shot. So we know our radius here is 18. So let's do B first. Find slowest velocity at the top. And so my acceleration is simply going to be g, and that's going to be a centripetal acceleration, which is going to be v squared over r. So I can then say that v squared equals ac times r, and then I'm going to square root that. And I'm going to get 9.8 times 18 square root. And so the velocity at the top is going to be, I believe that's 13, so 9.8 times 18, square root that. So it's going to be 13.28 meters per second. So that's the slowest velocity I could go at the top and still make it. If I go any slower, I'm not going to have the momentum to continue along the track. I'm actually going to start falling off of the track. So then, let's find velocity to enter the loop-to-loop. And with that, I'm going to use the concepts of energy, right? So when we get up here at the very top, we're going to have both energy due to gravity and kinetic energy. At the bottom here, then, we would just have kinetic energy. So we know that our height here, h, is going to equal 2 times my radius. So I'm going to set up this equation where my kinetic energy initial has to equal the gravitational energy plus the kinetic energy at the top. So that's going to be 1/2 mu squared equals mgh plus 1/2 mv squared. And v, this is what we solved for up there. That's that 13.28. So looking at this, my masses actually go away, which is pretty nice. And then I'm going to be left with 1/2 u squared equals gh plus 1/2 v squared. And then I'm just going to multiply each side by 2. And then I'll square root. So my u is going to equal 2gh plus v squared square root. So that's 2 times 9.8 times 18 plus 13.28 squared and square root. And that's going to give me about 30 meters per second. So that's how fast, that's the slowest speed that I can have to enter the loop, because then as I go up the loop, my kinetic energy is going to turn into potential and kinetic. I still need kinetic because I need to have some velocity here to stay on the track, and then I'll may convert back to kinetic energy as I leave the loop. But 30 meters per second as I go in, that energy then is going to be converted into gravitational, but I'm still going to have 13.28 meters per second at the top with kinetic energy. So hope that makes sense. It's a little bit tougher of a problem, and I don't like when they don't ask the questions in the right order, but I hope that makes sense of how we would go through that question.